Dear friends, we are into the next section, that is representing a binary tree. Of course, this should have been done in the beginning after the definition of the binary tree. We will see binary tree along with a traversal as a program or as a function. Let's consider, we know when we have a node in a binary tree, it has got an element. A node will have minimum these items. We will have a value, call it an integer item. Then we will have two pointers. Let's call them as left and right pointer. These pointers are pointing to its own type, meaning another node which is of the same type. So imagine this is a node. Okay, so that's a data item which is an integer. Then it has got two pointers. Let's call them left and right. Now these two pointers are going to point to, let's say, another node, which means of the same type. So they are pointers of the same type, like self-referential pointers. So if you look at a structure that is required to represent a node in a binary tree, will be of this. Let's call it node. It will have an integer data item, then two pointers of similar type, call it left and right. This should be able to represent a binary tree or a single node or a series of nodes. Having done that, we will go how tree traversal takes place as, let's say, as a function. Let's imagine we have declared a node, a binary tree. Let's imagine this is a tree that we have. And if we do pre-order, we have seen in the previous class, a pre-order where means root, left, right, we will get this particular sequence. Now let's see how we are using a recursion here. We have not gone into the creation of a binary tree, how to create, insert values. I thought this as recursion will be easier first. Then we are able to understand how the recursion in creation works. So let's look at this program. So T is a given tree, T, which has got number of nodes. So it's a recursion. So if, not while, make sure, sometimes confused. If T not equal to null, so first time when we come, T is not null, sure. So this is the first operation. So this is the first operation. First time when it comes here, T is not equal to null. T not equal to null. So it comes here. Printf T data. So this is T. T's data is 6. So it prints 6. Then imagine this is the first time recursion. So in the first time it goes to pre-order T left. So this is T. T left is this. So second time it comes here. T left. It calls the same function. So comes here. Now T is this. This is T. So second time T is, this is T. Sorry. So this is T second time. So now what it calls, T not equal to null. This is not null. So goes inside. This is the second time. Printf T data. So it prints 4. So we get 4. So this is the second time again. Now second time it calls again, go to its left. This is second time, pre-order T left. So this is T. T left is this. So it comes here, and this is, let's say, the third time. T. So third time when it comes, T not equal to null, it prints T data, that is the value 3 gets printed. And third time, so 1, 2, 3, third time, it goes, after having printed the root T data, it goes to the left, T left. T left is this, that means it goes actually this side. T left is null. So third time when it comes back, or fourth time, T not equal to null, but it is null. So this function will return. That means it comes back. So in this 1, 2, third, the fourth call has returned, that is this left. So it goes to T's right here. That means it will move to the right. This 2 is null. So the fourth, fifth time it stops, comes back. So this is over this node. It has gone to its root, gone to its left is null, right is null, so nothing. So it comes back. That means third time it returns, this left is over. So root was over, 4 was printed, went to 3, 3 is printed. So it comes back. So in this second instance, this was the left branching. Now the right branching is left. In the right branching, it comes in this line. So T right, it prints 5. Okay. Then again, because T data, this is T now, so T data is 5. It tries to go to its left, tries to go to its right. Both are null as here before, it will return back. So when we finish second, so seconds left is over, seconds right is over. So it now, the entire program, the left is over, 6 and its left is over. So it goes back to the right. So that is the first times the left spanning is over. Now right calling. So it comes here. Then again root here is 7. So it prints 7. Then it tries goes to the left. Left is null. So it comes back. Goes to the right. Right there is a tree. So again when it comes. So if you count, this is first, second, third, fourth, fifth, 6th, 7th, 8th, and 9th, 10th, 11th. So here when it comes, this is again, this is a T now. T not equal to null. This is not null. So it prints a value T8, 8. Then it tries to go to its left, tries to go to its right. Left is null, right also is null. So it comes back. So with that, the program returns. So it works like a recursion calling. So each time T is the node that is passed. So if this is T passed, then its root is taken. Then when it calls its left, it goes to its left. So by recursion, it prints all the values. Similarly, when you have other traversals like in order, post order, what changes is only the order of this. For example, in order, of course, the printing value will come in the center. So this would be replaced. This would come here, the center. And if it's a post order, the root would come last, left, right. So I think that should be clear. I would request you take this, go through the example as a program. It's a recursion, so easy to understand, but quite difficult sometimes to grasp. You need to work on this step by step so that we will be able to understand and grasp this. Thank you.